Welcome to Circuit Masterclass, your go-to channel for everything in power systems, transmission, and distribution engineering. Don't forget to check out circuitmasterclass.com for in-depth blogs and bonus content. We have provided the website link below in the description. Let's get started.
Subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment.
We shall discuss here in this video the very basic principle of the LBB protection scheme. We shall explain the exact working principle of the LBB protection scheme. Before going to the actual discussion, we will just try to recall our concept regarding what LBB is. LBB is the short form of local breaker backup. There is a special type of relay. We call it an LBB relay. We also call it a breaker failure relay. This is because it only functions when the circuit breaker associated with this relay fails to open during a faulty condition. So we can say the LBB is a kind of protection relay that facilitates isolating a fault when the main breaker connected to the faulty zone fails to isolate the fault. If we go directly through an example, we shall clearly come to know about it. Suppose this is a single bus with a sectionalized CB. This is a transformer bay. This is a line bay. This is another line bay. This is another, and this is another one. This is the second transformer connected to the bus. At this moment, both the transformers are running in parallel. This is the LBB relay connected to the CT secondary of this line feeder. Here we should note that we normally connect the LBB relay with a dedicated protection core of the CT, but if that is not readily available, we can connect it in series with another relay on the same core. In the figure, we have connected it to a dedicated core, but we can do it the other way as well. Here, this one is another relay, and we have used the same core for both the LBB and this relay. Although we are showing the LBB relay of this feeder only, LBB is present in each feeder. To maintain the clarity of the diagram, we are just showing the LBB of one feeder. For the rest of the feeders, you can just imagine. This is the 86 relay, master trip relay. Suppose a fault occurs in that feeder. So the protection system of the feeder activated, and it actuates the 86 relay. Then 86 relay sends the trip command to the circuit breaker of the feeder. At the same time, this 86 relay sends the activation signal to this LBB relay. Then LBB starts its timer. Now, suppose this breaker associated with this feeder gets tripped. Therefore, the fault gets cleared. After the successful tripping of the breaker, the LBB timer will reset. We normally keep the preset value of timer as 200 milliseconds. Now we come to another scenario where the circuit breaker is stuck and does not operate during a fault. Suppose again a fault has occurred in that feeder. In the same way, the protection relay will sense the fault and actuate the 86 relay to trip the circuit breaker. But somehow, the circuit breaker fails to trip. Maybe due to mechanical jamming, maybe due to the sticking of the moving contact, maybe due to some failure in the DC control circuit, maybe due to a defect in the tripping coil or tripping circuit. This breaker fails to open, but the LBB has already started its time counting from the instant the 86 relay was activated. Therefore, just after 100 milliseconds, the LBB relay will send a direct pulse to the tripping coil of this circuit breaker. If everything is alright, the circuit breaker will trip during the second attempt and the fault will be cleared. LBB relays reset just after successful retrip operation. Because these relays reset as soon as CT secondary current stops flowing through the current elements of LBB. At that stage, the LBB relay uses 3 input signals to judge whether the associated circuit breaker has tripped or not. The condition of the 86 relay, this means the 86 relay is in its lockout position, indicating that it has already operated. The breaker auxiliary contact. This checks the condition of the auxiliary switch of the breaker to determine whether the breaker is in the open or closed position. If the normally open, NO, contact of the auxiliary switch is in the closed position, and if this status is communicated to the LBB, then the LBB can understand that the breaker is still in the closed position. Current in the circuit, if a fault is present, there will be fault current in the circuit. So if the CT secondary feeds current to the LBB relay, then the LBB determines that the fault has still not been cleared. If these three conditions are fulfilled, then after 100 milliseconds, once the timer expires, the LBB will send a trip signal to the associated circuit breaker. Now think of another condition. When, after a retripping attempt by the LBB, the circuit breaker still does not open. In that case, the timer of the LBB will continue and wait for another 100 milliseconds. At the end of a total 200 milliseconds from the fault initiation, the LBB sends a trip signal to the individual breakers connected to that portion of the bus. So this LBB relay will send a trip signal to this breaker. Trip pulses will be sent to this breaker, as well as to the bus coupler or bus sectionalizer breaker, and all of them will open together to isolate the faulty portion and thereby clear the fault. Sometimes, instead of sending individual trip signals to each breaker, the LBB relay simply actuates the busbar protection of this section of the bus. Once the busbar protection relay is actuated, it will trip all the breakers of this portion of the bus through its trip relay, which is relay 96. At last, the LBB shall reset. Sometimes it becomes necessary to isolate the line from the far end as well. In that case, the LBB also sends a direct trip signal to the far end breaker. The LBB will trip the far end breaker of this feeder if the scheme is designed accordingly.
If you found this helpful, don't forget to subscribe, like, and tap the notification bell. Got questions or want us to cover a specific topic? Leave a comment. Thank you.